Hello everyone, welcome back to another episode of Common Errors. Today we will be covering the common errors that come with dealing with exponents and their properties. But before we start covering the common errors, we're going to have a small lesson pertaining to these properties. Let us begin with writing the expression a to the x. This could be read as a to the x or a to the x power. So, the different components of this expression are as follows. This is the base, and this is the exponent. You aren't always going to see it as this. This may be a variable at times and a number at times. This may be a variable or a number at times. So they're interchangeable. So let us begin with talking about rewriting expressions. The expression x squared could be easily rewritten as x times x. The same goes for a number. 4 squared could be rewritten as 4 times 4. Now, the exponent won't always be 2, so it may be more complicated. It may get to be perhaps x to the 4th, where this will be rewritten as x times x times x times x. So 4 x's. Now, it may get even more complicated than this. With your expressions, you may have a number in front of it. Do not let this confuse you. This is simply 6 times n cubed. You could picture a little multiplication symbol right there. So this too can be rewritten as 6 times n times n times n. So now that we have the fundamentals down, let us begin with the first part of our lesson. Dealing with exponents, or expressions that are being multiplied. So perhaps 4 cubed and 4 squared. Now, this may look complicated, but this is just a matter of rewriting it in your head or on your paper. So, 4 cubed could be rewritten as 4 times 4 times 4, and 4 squared could be rewritten as 4 times 4. Now, there's something that you must keep in mind. When dealing with parentheses, almost always entail multiplication. So when you see this, that's simply another way of writing that. So this entire thing could be rewritten as 4 times 4 times 4 times 4 times 4. Now, using our fundamentals, 4 times 4 times 4 times 4 times 4 could be rewritten as 4 to the 5th. Now we'll apply these same concepts to a harder expression. 2n squared times 4n cubed. Okay. So you see this, and as we covered earlier with the 6n cubed, this is simply 2 times n squared, and this is 4 times n cubed. So again, you could rewrite it as 2 times n times n times 4 times n times n times n. Again, viewing the parentheses as a means of multiplication, this could be rewritten as 2 times n times n times 4 times n times n times n. Well, you see two numbers here, and because it's multiplication, it doesn't matter which two things you multiply. You can multiply this 2 to this n, or this 2 to this n, or this 4 to that n, because it's multiplication. They're all going to get multiplied eventually. So this could be rewritten as 8 times n times n times n times n times n. Again, counting our variables, 1, 2, 3, 4, 5. This is a times n to the 5th. In some cases, of course, rewriting it is not ideal. For example, n to the 14th times n to the 16th. In this case, you wouldn't want to write n times n times n times n 14 times, and you wouldn't want to write n times n 16 times. It's too much work. The most efficient way to handle this is acknowledging the fact that because they have common bases, it's first step, common bases. Second step, they're being multiplied, right? Parentheses, just another way of writing multiplication. This entire thing is a matter of adding the exponent. Because of their similar bases and their multiplication, this could be rewritten as an addition problem for the exponents. So this would just be n to the 30th power. Now we move on to part 2 of our lesson. And this is when exponents are multiplied. So let's start with x squared squared. Okay. So before you start adding these two exponents, it must be acknowledged that, well, you can't do that because of this multiplication, or this parentheses. This could, however, be rewritten as x times x, right, squared. Now, covered in the distributive property, this squared would apply to both numbers. As covered by the distributive property, this number would be distributed to both numbers or variables inside the parentheses. So this would be rewritten as x squared times x squared. Furthermore, if you need to, you could rewrite this again as x times x times x, which again is just x times x times x times x, which could be rewritten as x to the 4th. Another example is when we're not dealing with variables, we're actually dealing with numbers as our bases. So we have 2 to the 4th power times 3. Well, using this property and skipping most of these steps, you could skip almost all of these steps and go straight here, knowing that these two would just be multiplied to give you your answer, which would be 2 to the 12th power. Now, a more complicated problem, I'll put a star next to this one, is when you get both properties and you use them together. So, you get the common base of 2, and you cube it, and you put that to the 4th power. Again, with the common base of 2, you square it, and you put that all to the cube power, and you make this to the 5th. Now, you're looking at this and you're probably crying due to the number of exponents and numbers, but this is just a matter of application of properties. Let's go through the first step. Okay, they have a common base. Cool. And they are being multiplied, which is good, but we have these nasty exponents in the front. Not stopping us from adding these two exponents. So it's just a matter of multiplication now, over here. So, let's break this apart. So 2 cubed to the 4th power, this could be rewritten as, you guessed it, 2 to the 12th. And this takes a bit more. So, 2 squared to the 3rd to the 5th. Well, 5 times 3. This right here is just another means of multiplication. So 5 times 3 is 15. Okay. And then this is still within a parentheses. So again, this means multiplication. So 15 times 2. This is still being multiplied. Would be 2 to the 30th. Now, this is another one of those instances in which you wouldn't want to write 2 times 2 times 2 times 2 times. That's far too much work, and especially for this one. So using our other property with common bases, it means you can add the exponents. So this would be 2 to the 42 power, or to the 42nd power. And that concludes our lesson. So now we move on to the common errors of dealing with exponents and their properties. Well, some kids overthink this negative. They think, oh, there's a negative, which means everything flips. So the x to the 4th stays on top, and the 8 flips to the bottom. There we go. No, this is incorrect. Before continuing, we will cover the fundamental law of a negative exponent. Well, when something is to the negative power, it flips to the opposite position. So if it was in the numerator, it flipped to the denominator. If it was in the denominator, it would flip to the numerator. Yes? Okay. So the correct way to tackle this problem would be to leave it alone, because it is already fully simplified. Okay. So moving on to example 2. It goes 4x times 4 times x squared times y to the negative 3rd squared. The common mistake made here is they distribute this exponent to the variables. Cool. So the answer is 4x to the 4th times y to the negative 6. Awesome. Well, that's also incorrect, because when dealing with parentheses and exponents, this number must be distributed, quote unquote, to everything inside the parentheses. So this, a good way to keep this in mind is that every number by itself is to the 1st power. So technically every number has an exponent. It's kind of secret. So this 2 would go to the negative 3, to the 2, and to the 1 over here. So the correct answer would be, well, 4 squared times x to the 4th times y to the negative 6, which could be rewritten as 16 x to the 4th all over, keeping in mind that there's a negative exponent here, y to the 6th. And that concludes today's episode of Common Errors.